Here's a part most people miss. Building a road around a mountain looks cheaper on paper, but China doesn't build for next year, it builds for the next 30. Mountain roads twist, climb, and every curve adds fuel costs, delays shipments, and increases the chance of deadly accidents. A tunnel does the opposite. It cuts straight hours of travel into minutes. That time savings compounds day after day, year after year, until entire regions feel closer than they ever were before. Not just about speed. Tunnels quietly solve problems roads never can. Landslides don't care about guardrails. One bad storm can shut a mountain highway for weeks, sometimes forever. Almost entirely. No falling rocks, no blind hairpin turns, no seasonal shutdowns. What looks like a trip that doesn't end in disaster. There's also a strategic layer most countries ignore. Faster travel reshapes where businesses invest and where talent flows. Remote areas stop being isolated, jobs spread outward, trade moves smoother. It pays for itself not once but repeatedly by keeping people, goods, and entire economies moving without interruption. But deciding to is only the first hurdle. The real challenge is choosing where to cut into a mountain, because one wrong decision underground can end a project before it ever begins.
Arrives on site, the real work is already underway, and this is where most tunnel projects quietly die. You can't just point at a mountain and start drilling. The difference between success and catastrophe can be a few meters of unstable rock. Engineers spend months, sometimes years, studying what geological maps are cross-checked against fresh data. Test routes are proposed, rejected, then redrawn again. Boreholes are drilled into the ground to sample rock strength, pressure, and moisture. Ground-penetrating radar scans reveal hidden fault lines, underground voids, and water pockets that could flood a tunnel in minutes if hit at the wrong angle. Water is one of the biggest threats. An unseen aquifer slurry nightmare. Natural caves can collapse without warning. Even rock that looks stable on the surface can be hit. Pressure is released. That's why routes that seem perfect on paper are often abandoned entirely after testing. At the same time, something else is happening. While surveys continue, factories begin preparing in parallel. Tunnel segments, support rings, ventilation systems, huge parts of the tunnel are manufactured before excavation. Overlap is intentional. It removes downtime later and locks the project into a tight, efficient schedule. Only after the test does the green light appear. And when it does, the planning phase ends instantly. Because the moment digging begins, there's no room left for guesses, only precision. When China brings out the machines that make all of this possible. This is where the gap between China and the rest of the world really starts to show. When most countries, one of the first questions is where to buy a tunnel boring machine. China doesn't ask that question. It asks how fast one can. China is the world's leading manufacturer of tunnel boring machines, and that changes everything. These machines sitting in a warehouse. Every TBM is custom built for a specific mountain, a specific depth, and a specific type of rock. Stone, water-heavy soil, each condition demands a different configuration. Before a single piece of steel is cut, engineers build a full 3D digital model to simulate pressure, heat, vibration, and failure scenarios. Weak points are redesigned, components are reinforced. Machine survives every test, does the real construction begin? Then comes the scale shock. These machines aren't just big, they're overwhelming. Hundreds of meters, weighing thousands of tons. Some are so massive they push the limits of what modern engineering can even move. Every motor, hydraulic system, and sensor eliminating delays and supply risks. Transporting one is an operation on its own. The TBM is taken apart into giant sections, reassembled near the mountain like a mechanical puzzle. And once it arrives, it doesn't go straight into the rock. Because charging a machine like this directly into a mountain would be a Instead, China prepares something far more controlled and far more precise.
Here's the part that surprises most. A tunnel boring machine never just rams into a mountain. Doing that would destabilize the rock instantly and risk a Instead, everything begins with something called a launch shaft. This is a vertical cavity carved deep into the ground at a carefully selected point. Test this location repeatedly to make sure it can handle extreme pressure and vibration. Only after it passes every check does the begin. Piece by piece, the TBM is lowered into the shaft using cranes powerful enough to lift entire head alone can weigh hundreds of tons, making it the most dangerous part to position. Once underground, the machine is into place. Now, the digging can finally start. At the front, the cutter head begins to rotate, grinding against solid. But rotation alone isn't enough. Hydraulic systems brace the machine against the tunnel walls and push it forward inch by inch, applying that even the hardest rock eventually gives way. What makes this process terrifyingly efficient is what happens behind the cutter head. As the machine advances, robotic arms prefabricated concrete segments along the tunnel walls. These segments lock together to form a reinforced ring, preventing collapse and creating a stable surface for its next move. The tunnel is being built at the exact same time it's being dug. Meanwhile, crushed rock and debris are mixed with water, slurry, which is pumped back to the surface. Nothing is wasted. The solid material is separated out and the water is cleaned and reused, allowing the operation to stop. The result is a relentless rhythm. Cut, support, push, repeat. Hour after hour, day after day, deeper into the mountain with mechanical precision. But even with all this control, danger is never far away, because hitting inside the rock are threats no drill bit can see. From the outside, a tunnel boring machine looks unstoppable, but one of the most hostile environments on Earth. Every meter forward comes with risks that can shut everything down in seconds. Inside the mountain, invisible threats are everywhere. Hydrogen sulfide can leak without warning, turning the air toxic in moments. Oxygen levels can drop just as fast. That's why modern TBMs constantly sample the air, scanning for gases that can knock workers off before anyone realizes what's happening. If readings spike, alarms evacuation begins. Then there's the ground itself. Rock under pressure behaves unpredictably once it's cut. Sudden shifts can trigger cave-ins or trap the machine entirely. To stay, TBMs use seismic prediction systems and ground scanning radar to look several meters ahead of the cutter head, searching for weak zones or voids before they're breached. As rock is crushed, fine particles flood the tunnel, threatening lungs and visibility. Powerful ventilation systems run alongside the machine, contaminated air out and pushing fresh air in, creating a controlled environment where humans can survive next to industrial scale. Precision is just as critical. These machines don't wander. Navigation systems guide the TBMs so accurately that after drilling for miles, it may be only inches off. Could mean missing the exit shaft entirely. And yet, even with all this technology, TBMs aren't invincible. In the wrong conditions, they can sink, stall, or become permanently buried underground. Their losses. Which is exactly why China doesn't rely on just one method. When the ground refuses to cooperate, they turn to something far more aggressive. When a tunnel boring machine the ground, when the rock shifts unpredictably, densities change without warning, or the route bends too sharply, China and this alternative is far less forgiving. Instead of cutting, the mountain is broken. Controlled blasting has been used,
but China refined it into a precise, calculated system. Every step begins with extreme surveying. Just remove rock, they send shockwaves through it. If those vibrations aren't understood, the mountain can answer back with a collapse. Approved, drilling rigs punch deep holes into the rock face ahead. These holes aren't random. Their depth, spacing, and angle are engineered to direct backward into the completed tunnel. Explosives are packed carefully, fuses attached, and timing is set down to milliseconds. Workers don't hesitate. They retreat fast because what comes next is violent. The blast hits like a hammer from the inside. Massive rock into manageable debris. Dust floods the tunnel instantly, thick enough to blind cameras and choke the air. Immediately, clearing the dust in minutes instead of hours. Only then can inspectors move forward, and even that isn't guaranteed. Explosions weaken surrounding rock. Before anyone touches the rubble, structural integrity checks are done using scanners, sensors, and sometimes remote-controlled machines. The area passes inspection, temporary supports go up first. Only after the tunnel is secured do crews remove the debris for the next blast. Then the cycle repeats. Drill, load, detonate, stabilize, clear. This method is fast, but unforgiving. Calculation doesn't stall progress, it ends lives. That's why even in China, blasting is slowly being phased out. It was razor thin. So engineers searched for a safer option, one that adapts to unstable ground instead of fighting it head-on. This led to a method that lets the mountain move without falling apart.
This is where tunnel construction stops feeling like brute force and controlled persuasion. When blasting is too dangerous and tunnel boring machines can't adapt, China turns to sequential, a method built on patience and precision. Instead of removing the entire tunnel at once, the excavation is broken into sections. The top portion is carved out first, followed by the sides, then the bottom, and finally the center. Each cut is deliberate and immediately reinforced. Concrete is sprayed onto exposed rock within minutes. Steel ribs and rock bolts are installed. It's time to shift. Something subtle happens during this process. The mountain doesn't collapse, it adjusts. As material is removed in stages, the distributes its weight and settles into a new balance. Engineers monitor this constantly. Sensors line the tunnel walls, measuring tiny deformations that signal or starting to fail. If a section begins to warp, work stops instantly. More support is added. Excess material is shaved away. Real time until stability returns. It's slow compared to a tunnel boring machine, but it's far more forgiving in This method also offers flexibility no machine can match. Irregular tunnel shapes, changing cross sections. Sequential excavation handles them all. That's why it's become one of China's go-to solutions for complex mountain terrain. Progress comes meter by meter, section by section. The tunnel grows while the mountains adapting together instead of fighting each other. But carving the passage is only half the story. Even once the breakthrough is made,
When the tunnel finally punches through the other side of the mountain, it feels like the finish line. But in reality, it's just another phase. The tunnel that's been dug isn't yet a tunnel that's safe to use. First comes the machine itself. A tunnel boring machine can't just be abandoned in the open. In some cases, it's dismantled piece by piece, lifted out through a reception shaft, and transported to storage or recycling. But many TBMs are so customized that when that happens, something unusual occurs. A large cavity is dug near the exit. The machine is lowered into it, and it's buried permanently beneath layers of earth, sometimes that will soon carry traffic above it. Next, the temporary structures disappear. Launch shafts and reception shafts are filled back in, sealing the mountain as if nothing ever happened. Under begins its transformation from construction site to long-term infrastructure. Permanent linings are installed where needed. Waterproofing layers block seepage. Fire-resistant materials are applied in high-risk zones. Ventilation systems, emergency exits, lighting, and drainage are integrated into a single control. Sensors are embedded throughout the tunnel, quietly watching for shifts, cracks, or pressure changes long after workers are gone. Only after cars, trains, and freight begin moving through a space that once held solid rock. And even then, the work never. The structure is monitored for decades, with maintenance teams ready to intervene at the first sign of trouble. That's the part most people never think about. Tunnels fast, it builds them to last, and that long-term mindset is what keeps mountains passable, economies connected, and travel times shrinking year after year. Question: is this just engineering efficiency or a strategy that reshapes entire regions beneath our feet? When you zoom, aren't the real story. They're the result of something bigger. Speed comes from planning years in advance. Safety comes from controlling underground. And efficiency comes from doing everything in parallel, designing, manufacturing, surveying, and building at the same time. Isolated projects, China treats them like pieces of a system. Machines are custom built for one job, buried when their purpose is fulfilled without hesitation. Methods shift depending on the mountain, not political pressure or sunk costs. If a technique becomes phased out, if geology changes, the plan changes with it. That's why these tunnels keep appearing faster than expected. Mountains are easier, but because the decisions are ruthless and long-term. Every hour saved compounds. Every avoided prevents disasters years later. What looks like brute force is actually discipline on a massive scale. And that's the part. These tunnels aren't just cutting through rock. They're compressing distance, reshaping regions, and quietly redefining what modern infrastructure. The real question isn't how China builds tunnels so fast. It's how far ahead you have to think to make speed look effortless. At first glance, worry about machines, explosives, and raw power, but that's not what actually sets China apart. The real advantage is at scale. Every tunnel is treated as a long-term asset, not a short-term win. That mindset changes everything from how machines are built to why entire methods are abandoned without hesitation. While others debate budgets year to year, China plans decades structure that reshapes how people move, where businesses grow, and which regions stay connected no matter the terrain. Start becoming lines on a map. That's why these tunnels feel almost unreal when you see them completed. They aren't just engineering feats. Their speed, safety, and strategy are aligned under one system. So when the next tunnel opens beneath a mountain that once took hours to cross, wasn't just about drilling faster. It was about thinking further ahead than anyone else and committing fully to the outcome. What almost never gets talked about is the price paid. Tunnel opens and traffic flows smoothly, the story feels clean and complete. But underground, the risks don't end when mountains continue to shift. Water keeps searching for weak points. Pressure never truly disappears, it only redistributes. These projects have absolute tolerance for loss. Tunnel boring machines worth hundreds of millions can be buried forever without ceremony. Entire designs are abandoned mid-plan if geology disagrees. Years of preparation can vanish if sensors be corrected safely. In many countries, that kind of sunk cost would stop everything. In China, it's accepted as part of the process. Workers operate in environments where a mistake isn't recoverable. One hydraulic failure, one misread pressure spike, one gas pocket. The margin for error is thin, even with automation and sensors watching every move. That's why training are treated as seriously as the machines themselves. And then there's the long-term question no one can answer yet. As tunnels becomes the real challenge. Decades from now, these underground networks will require constant monitoring, upgrades. The speed of construction shifts the burden forward in time. What's built fast must be preserved carefully, or risk becoming a liability. Still, that's the calculation being made. Compress distance now, accept risk early, pay the price up front. Control over geography itself. Mountains that once divided regions now quietly erase from daily life. Tunnels are built so quickly, they're asking the wrong question. The real question is, who's willing to commit this deeply for the costs don't end when the rock stops breaking? Because once you start reshaping the ground beneath an entire country, there's no easy forward. What's happening right now is only the early phase of something much bigger. These tunnels aren't isolated victories, they're rehearsals. Each data into the next. Every meter drilled teaches engineers how different rock behaves, how pressure shifts over time, and how human systems respond under extreme conditions. The mountain becomes a classroom, and the lesson never really ends. Next is deeper, longer, and far more ambitious. Future tunnels won't just pass through mountains, they'll pass under layered tunnel networks, parallel freight and passenger systems, underground logistics routes designed to remove surface congestion. And the goal isn't just faster travel, it's redundancy, resilience, and control. Automation will push even further. Fewer workers exposed, more decisions made by predictive systems that can spot failure hours or days before it happens. Machines will adjust pressure, speed, and tunnels will become smarter over time, learning from their own stress and deformation instead of waiting for human intervention. And the most unsettling part? The level of infrastructure exists. Geography stops mattering in the way it used to. Mountains lose their power to isolate. Distance becomes negotiable. Regions that were once considered too viable economic zones. That shift doesn't just change transportation, it changes population flow, investment patterns, and political leverage. These projects feel different. They aren't about proving capability, they're about rewriting limitations. When China drills through a mountain, it isn't just building a tunnel, it can bend nature without breaking it. And the deeper this goes, the harder it becomes for anyone else to catch up. Not because the machines are bigger, faster, but because the mindset behind them is already years ahead. The real transformation isn't happening on the surface, it's happening relentlessly beneath the ground, one mountain at a time.